Hi, this is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Today we're going to be going over the ATU-100. This is a newer version of the open source antenna tuner. This one was provided by GooZeeZoo, an Amazon store. This particular version is the dual powered version. It can run off of line, which is a 12 volt input, or it can run off of its own internal battery. Let's get into it and see how this one performs. This one, you can see I've already taken the screws out of the top two screws, front and back, so we can get into the internals and look it over. This one is built a little better than others that I have seen. One thing that they've done is they've put some, I don't know if this is called potting compound or what it's called here on the inductors to lock them into place, keep them from being affected by vibration or from moving around. And it's primarily on the bigger inductors on the cores that are mounted on cores. And we got some smaller inductors here, and here that don't have cores, so they didn't use the silicone or potting compound on them. This is seems to be very well built. They've kept the leads to the coax very short from the circuit board to the center conductor of the coax. They've also, instead of using wires, they've used some straps here on the ground lugs going from the SO239 connector to the printed circuit boards here on both sides. This is the input from the radio, and this is the output to the antenna. This particular version also has two buttons back here for automatic and bypass that can be operated to select which mode you want. And when you hit auto, it will automatically match the impedance from your antenna to your radio. Or if you want to just bypass the tuner altogether, you hit this and it routes the signal straight through from RF in to the antenna out. This one comes, like I said, it has an internal battery, and that battery is a 5,000 milliamp hour battery, which should power this for days without any issues. And it can also be charged here from the USB-C port on the front panel. As far as what comes with it, you do get a charging cable, USB-C, and it comes with some rubber feet, which I've already taken off of this and put onto the bottom. And you don't want to put it over the screws because you want access to the screws, so just put them here somewhere on the sides on the smooth part so it will stick better, and you shouldn't have any issues with that whatsoever. You may see some scrolling here on the screen, but that you don't see that when you're looking at the screen itself. That's just because of the scan frequency of the camera and the refresh rate on the screen itself. But when you're looking at it with the naked eye, you don't. It's very stable. You don't see any flicker whatsoever. This is just an artifact because I'm recording it with the camera. But you have power, SWR, and then you've got inductance and capacitance that it's currently using. And you notice right up here there's a dot. That means it's in auto mode. If I hit bypass button on the back with my left finger here, you notice that changes to an underline. So that's how you can tell what mode it's in. There it's in bypass, and there it's in auto. Or you can just turn it off, and there the auto tuner is on. So whenever RF is applied, it's going to check your SWR, and if it's greater than 1.3 to 1, it's going to try to tune it. I believe that's the cutoff SWR for this particular unit. It's made to work 1.8 to 30 megahertz, and it has a maximum of 55 megahertz input. You don't want to go higher than that. It could damage the unit. And it is actually capable of tuning up to that, but it works better down in the HF bands. So let's get this thing connected and see what it does. I'll try to get an antenna. Well, I've got some antennas that will not tune on the 80-meter band and the 40-meter band. So let's see what it will do for those. Okay, we're going to try down on 160 meters to tune this 40-meter delta loop antenna to see if it can make it usable. Let's got it on 1.803, got it in power turned down somewhere around 10 watts so as not to burn up the radio or the tuner. So let's give it a shot. Now this is going to be a stretch, you know, if it works at all. So let's see what this thing can do. You could probably hear everything churn, all the relays churning in there, and we got it down to a 2.28, which is not fantastic, but like I said, this is a stretch to tune a 40-meter antenna down to 160 meters. Got 84% efficiency. You've got 12 watts in, 11 watts out. So not bad. It's not perfect, but like I said, that's a stretch for a tuner. You know, that's not even close in resonance. So let's bring it up to the 80-meter band. Let's go ahead. We can leave it like this. I prefer to reset it. Just press the button, it goes to reset, and it takes your inductance and your capacitance back down to 0. And we're still in auto mode, indicated by the dot here. So approximately a second or so after you start transmitting, it will measure the SWR and then try to bring that SWR down. So let's do that again. And it very quickly, it's 99% at 12 watts in, or 11 or 12 watts in and 11 watts out. So it's very, very efficient there. And here we've tuned an 80-meter antenna to the 40-meter band. The 40-meter loop is also not very resonant on 17 meters. It does very well on 40 and 20. So let's go up to 17 and see what it can do here. I'm going to put it into bypass mode, which is indicated by the underline here, to see what the antenna reads without the tuner. Okay, we got 3.7 SWR, so it's 66% efficiency. So obviously not a good match on 17 meters. So let's turn it back to auto mode and see what it will do here. And we'll do reset because that still has the tune from the 80-meter band. We'll start out from 0. It's not required, but I just like to do that. Okay, it didn't take long. We got 12 watts in, 12 watts out, 99% efficiency, 1.2 SWR. It works. What can I say? It's recommended that you always tune it on low power. Will it tune on high power? Yes. Assuming that your SWR is not way out of the ballpark. The thing is, the longer your transmitter sees a higher SWR, and the tuner itself, the longer it sees that higher SWR, the more chance you have of damaging one or the other. So you want to lower the power, preferably if you think the antenna is not going to be very resonant at that frequency. One way you can check is just key it up. If it's very high SWR, unkey it as soon as possible so as not to damage anything. Turn it to a lower power, preferably somewhere around 10 watts, because it takes at least 5 watts to activate the tuner. You have to have a minimum of 5 watts for this tuner to activate the tuner. So it's not really made for extremely low power QRP. This is the ATU-100. It's made for 100 watt transmitters. We tuned on 17 meters, brought it in very good, and one of the big advantages of this unit is its dual power. You can run it off of the internal battery, if you're going portable for POTA, SOTA, or whatever, just going portable. It'll run, in my estimation, days on this 5,000 milliamp hour internal battery if you have a full charge. The big advantage of these units is they're small, they're portable, they do the job they're intended to do. I think it's good value for the money. This one has some advantages in that it also has what they call a test mode. And I'll show you that here in just a minute. But these are the bands I know that this particular antenna is not very resonant on. So that's the reason I picked those bands to demonstrate on. The other bands, they don't have any problems tuning up. And we wanted to give it a little challenge, so that's what we did. So let me get the NanoVNA set up, and let's do a few tests using it. Okay, we've got our NanoVNA connected, and right now the tuner is off. We're on the 20 meter band, and since this is I got it connected to my 40 meter delta loop, we have a very low SWR pretty much all across the band. One of the things that you can do to test to see if all your capacitors and inductors are working, or if you can also use it to manual tune, but you got to be really careful if you're trying to do a manual tune that you don't have your transmitter keyed up too long. So it's not really that good for a manual tune, but it is possible. I just wanted to tell you that. So to get into test mode, the two buttons on the back, right back here, push them both in at the same time and then turn it on, whichever power supply you're using, whether it's the line supply or the internal battery. Turn it on. It'll indicate here that it's in test mode. Okay, and so we got 0 inductance and 0 capacitance, and you notice right up here beside the W, that is an L, which indicates inductance. If I do a long press here, it changes to a C for capacitance, so you can change either one independently. Okay, here we are in test mode and inductance mode with the L indicated beside the W here. We've got 0 inductance right now. Let's watch the scan here and see how it changes as we change the inductance. It raised the SWR. There's the second step. There's the third. And you can see also as the SWR goes up, where the low SWR is starts going to a lower frequency, because with adding inductance we're effectively lengthening the antenna. So that's what you'd expect to happen. And then it really jumped on that one. But it's interesting to see how it affects things. I wonder, there may be some other uses for this as well, since we know you could use this to find out what size coil you would need to add to effectively lower the resonant frequency of an antenna. It would tell you pretty close how many microhenry coil you would need. That would be an interesting application for this. So as you can see though, the trace here for the SWR changed significantly when we changed the inductance here. So let's step that back down to 0. All right, we're back down at 0. And let's do a long press here to get in capacitance mode, where it's got a C indicating here now. Let's change the capacitance. Again, it raised the SWR. As soon as we put any capacitance in it, we put in 22 picofarads. Raise it again. Anytime you change the reactance, regardless of whether it's capacitive or inductive reactance, it changes the SWR and it'll change the resonant frequency on your antenna. Let's look at it, look at the Smith chart. So here we've got the Smith chart. Since we're only on one band at the moment, we're at 14,150 megahertz. Let's take the capacitance back out of it, and notice the line here in the middle. When you're on that line, you've got strictly resistive load. Anything below that line is capacitive reactance. Anything above the line is inductive reactance. So this could be used as a learning tool also to help you read and understand the Smith chart. Now this circle right here, this circle is the 50 ohm impedance circle, and we're outside that circle right now, and we're reading 41 ohms. So let's go ahead and continue changing the capacitance. We're reducing the capacitance. The marker should be getting closer and closer to the resistive load line and also to the 50 ohm line every time we reduce it. There's another one. Wow, that brought it closer to 50 ohms. And what are we reading? We're reading 49.8 ohms right now. But we're still got a little capacitive reactance. Take out the next bit, we're at 10 picofarads, so we're still a little bit capacitive. And our resistance now is 52 ohms. And now we've got all of the capacitive reactance out of it. We're on 0, but our resistance is at 55 ohms. We're inside that circle now, and it's at 55 ohms, as you can see right up here. 55 ohms is the real impedance on that antenna. It is what it is. It's close. But you know, I just thought this would be interesting to show how you can experiment, learn a little bit, understand both your tuner, what the tuner is actually doing, as well as how that looks on a Smith chart. Hope that's helpful to you. So as it is, I mean, this little tuner I think is great. It's great value for the money. Now if you're running power, this is not going to do the trick for you. As you can see, I kind of like, I've got 3 different models. I bought this one I tested earlier, and this one I just got from GooZeeZoo. This one has some different features, but they're all based on the work done by N7DDC. N7DDC was the original developer, designer, and he open sourced it, and we're thankful that he did, because we can get these great little tuners now. And GooZeeZoo, from my experience, has been a good supplier. They're quick to work with you, help you to resolve an issue if you find an issue, and I think you get good value for the money. Like I said, there will be a link below where you can find this on Amazon from the GooZeeZoo store. Now they do have an identical model that does not have the internal battery. That's the only difference. This one has dual power capabilities. They do have one that has external power only. I requested this one with the internal battery because I use these a lot, portable, running POTA, or out just operating portable. So whichever one you want, I think you'll be happy with it. Thanks for watching. If you haven't already, subscribe. Give me a thumbs up. It helps the YouTube algorithm to boost the channel, and I appreciate that. This is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Hope you have a blessed day.